In this video, I will show you an example that how this new approach to prove two random variables are not independent works. So the word problem goes like this. An urn contains three balls, one with the number 1, one number 3, and one number 8 printed on. So three balls, one has 1, one has 3, and the other one has 8 printed on. Two balls are drawn one by one without replacement, and then we define two random variables. X is the number on the first ball, and Y is the number on the second ball. Basically, what we do is that we draw one ball, read the number, that's the value for X, put the ball aside, take another ball from the urn, and read the number. The second number you read is the value for Y. Then the question says find ex, ey, and exy, and and then check that if x and y are independent or not. Okay, so to do this example, it's obvious. Yes, we are taking these balls from the urn, and this is a stochastic process. So the best way to model stochastic process is stochastic or probability tree. So the first ball you take out, it's either 1, 3, or 8. Then you don't replace, so it means that in the second draw you won't have any 1. It will be either 3 or 8. It will be either, oh okay, if 3 was drawn for the first one, it will be either 1 or 8. And if you draw 8 first, then there will be only 1 and 3. And well, we need to know what are the probabilities. Well, in the first one, all of them, we do it randomly. So it will be 1 over 3, 1 over 3, 1 over 3. How about the second ones? Well, there were 3. We took out 1. So it means that the probability of all the outcomes for the second one are going to be half. Okay, why do we need this? Because we are going to find PDF table for X, Y, and Z. Oh, X, Y, and XY. So let's just start with the values. So X can be either 1, 3, or 8. How about Y? Y again can be 1, 3, and 8. How about X times Y? Means what? You have drawn, let me just do some small thing here. You have drawn two balls here. Now the numbers you multiply. It's 1 times 3, it can be 3. 1 times 8, it is 8. 3 times 1, again another 3. 3 times 8, we may get 24 also. And 8 times 1, again 8. So the possible values for xy, let me write that in black. It can be 3 or 8 or 24. Okay, so we need to find probability of each one of these guys. So let's just draw the PDF probability density table for each one of these guys. X, then probability of x being equal to x. For the second one, we can have y, probability of y equals to y. And then for the third one, let me just write this one as z, probability of z being equal to z. Okay, what are the values? Okay, 1, 3, and 8. The probability of each one is half. Oh, sorry, 1/3. The first one, the probability that 1 comes out is 1/3, 1/3, and 1/3. For the second one, we have 1, 3, 8 again. And as you can see, the second one, the 3 comes out. It has two branches here. first one gives me 1/3 times 1 over 2, 1/3 times 1 over 2, and when you add them, you will get 1 over 3. For the second one, sorry, that was for 3, but that will go same thing for 1 also. Let me do 1 first. So for 1, I have 1 over 3 times 1 over 2, which is 1 over 6 times 1 over 3 times 1 over 2. That's another 1 over 6. You add them, you get 1 over 3. So basically, all three values are 1 over 3, 1 over 3, 1 over 3. How about z? Well, z we already know that, or xy can get 3, 8, or 24. How about probabilities of getting 3? So to get 3, so let me just do this one again. To get a product equal to 3, I need either this branch 3 times 1 or 3 times 1 this branch. Yes, and the similar computation shows that this will give us 1 over 3 times 1 over 2 plus 1 over 3 times 1 over 2, and that's 1 over 3 again. How about 8? Okay, 8 can be got from here, so it can be this or this. Yes, and this is 1 over 1 over 3 times 1 over 2 plus 1 over 3 times 1 over 2, and you add them, you get 1 over 3. How about the last piece? Well, okay, that's again 1 over 3. That's it. So now we have the PDF table. Now we have to find E of X. It is you multiply row to the probability 1 times 1 over 3 plus 3 times 1 over 3 plus 8 times 1 over 3, and as a total it is 1 plus 3 plus 8 over 3, which is 12 over 3, and that is number 4. How about E of Y? Well, very similar computation. It will be 1 times 1 over 3, 3 times 1 over 3, and 8 times. That would give me 12 over 3, which is 4. How about this last piece? Okay, so E of xy, remember xy, z was another name for xy, is equal to 3 times 1 over 3 plus 8 times 1 over 3 plus 24 times 1 over 3. And if we add these guys, what we will notice is that this number is a bit different numbers. This is 11 plus 24 is 35 over 3. And 35 over 3, you see that, okay, can I simplify? No, I cannot. Okay, so I found EXY, EX, and EY. Now, check, this is part 2. EX times EY is 4 times 4. However, E of xy is 35 over 3. And 35 over 3 obviously is not equal to 16. What can I take from this inequality? I can say definitely that x and y are not independent random variables. Again, while sometimes you need to do more work, sometimes less, but the upshot for this example was that we first set up the experiment, we found the PDF of the random variables, we computed E of expected value of each one of them, and we we could check that EXY, which was equal to 16, is not equal to EXY, which is 35 over 3. So that means that X and Y are not independent.